Hi, good morning, and welcome to our webinar, Electrical Safety Planning and Techniques. Today is actually the first webinar of a planned series of two, where we're going to talk about electrical safety in a little bit more detail than we might otherwise be able to in a webinar format. But today we're going to focus on safety and avoidance of accidents. And then next month in July, we're going to focus on specifically PPE. And so we're going to make some references to PPE today, but we're not really going to get in depth into it today. So if you are interested in learning more about PPE specifically, we're going to do that next month. And in the chat section down on the bottom of your screen there in the lower right, I'm going to actually put a link to register for that webinar if you'd like to do that sooner rather than later. First, some housekeeping items. I'd just like to mention the number one question we get is, can I get a copy of the presentation? The answer to that is absolutely yes. At the conclusion of the webinar, you're going to receive an email from us and the GoToWebinar setup. So please just reply to that email. That'll come directly to me, and let me know if you want a PDF copy of that webinar. We are also recording the webinar today, so if you would like an actual video recording of it, if anybody misses the webinar or can't be here with us today, we're going to post it on our YouTube channel, and so if you would like that link, please just respond to me with that as well. So without further ado, we're going to do questions at the very end, but for right now, I'm going to turn it over to our presenter, Mike Chambers. Mike?
Hi, thank you, John. Thank you. Welcome, everyone. My name is Mike Chambers. I am from Denver, Colorado. I got into the electrical industry in the early 90s. After serving in the military, I tried a few different trades, plumbing, pipe fitting, roofing, and landed in the electrical industry. Brief description of some of the jobs I've been on. I was on the entire project for the Denver International Airport construction, Anheuser-Busch, the brewery in Fort Collins. I worked for Kaiser Hill out at Rocky Flats Nuclear Facility when we were taking that facility down. I've worked on quite a few area hospitals here in town, so I do have the experience and background on this subject matter. Let's take a look at brief history on NFPA 70E real quick. In 1911, the NFPA started to author our code book, 1911. In 1979, they came out with the first edition of 70E, the arc flash safety. So you can see there was quite a gap there between the initial code books written in 1911 to our first edition of safety. And you can see since then, we've come out with a new edition every 3 years. It coincides with our code book that is released the year prior to these subsequent code books. The NFPA does write 10 of our code books for us. National Fire Protection Association. 70E is one of them. Real quick, I'd like to identify the relationship between the NFPA, National Fire Protection Association, and OSHA, Occupational Safety and Health Administration. Basically, OSHA is going to set our rules, and the NFPA is going to help us follow those rules. That is their relationship. OSHA will hold employers accountable for changes to the NFPA 70E. It is not an assumed, it is a responsibility. The burden does rest on the employer, and it states here on the slide that ignorance is no defense. So the employer is responsible to identify the updates as they apply to the editions of the code book coming out. This one came out, the latest one was 2018. It was available for adoption January 1st of this year. I would like to identify with a very important definition. That definition is of a qualified person. What what is a qualified person? Who is a qualified person? And we follow this very closely in my circles in identifying who are qualified. One who has demonstrated skills, knowledge related to the construction and operation of electrical equipment and installations, and has received safety training to identify the hazards and reduce the associated risk. So basically, an individual who has the skills, knowledge, and safety training on a particular piece of equipment, task, or set of skills there. Not only being able to possess them, but to demonstrate that they have those abilities to work safely in our industry. I think it's also important to note who can qualify someone, and that is the responsibility of the employer. The employer is the entity that would identify who the qualified persons are. These individuals, while they're getting qualified, can gain certain knowledge and certifications outside of their employer, but it is their employer's responsibility. Some things that the employer may use to qualify someone would be their experience in the field, the reputation of the company, employees' years with the company, the different types of training the employee may have, different certifications. Maybe they've got some OSHA training, and they are possibly licensed. I want to make it also another view right now that you don't necessarily have to be a licensed person to be an electrical worker, and that burden falls onto the employer. What is covered in this code book is also very interesting. It's not only the installation, but also the removal, inspection, operation, maintenance, and demolition of electrical conductors, electrical equipment, signaling, communication conductors, and equipment and raceways. So it's real important to point out that it's all aspects of interaction in our electrical industry. Who is required to not only take this course, but also be aware of its hazards and how to avoid them. I'm going to go through a few definitions here and then help identify any particulars as we go here. The first one is arc flash hazard. Arc flash hazard is identified as a source of possible injury or damage to health associated with the release of energy caused by an electric arc. So basically, whenever we get our current flowing outside of its normal path, there's the potential, or as it says here in the first informational note, the likelihood of an occurrence of an arc flash. When this occurs and it cannot be put into a safe working condition or de-energized, then we must be protected against that hazard. The word shall will come into play quite a bit here. The employer shall protect us if it cannot be eliminated. The next one is arc rating. Arc rating is the value attributed to materials that describes their performance to exposure to an electrical arc discharge. The arc rating is expressed in calories per centimeter squared and is derived from the determined value of the arc thermal performance value, ATPV, or energy of break open threshold, EBT, should a material system exhibit break open responses below the ATPV value, which is possible from the manufacturers. Arc rating is reported as either ATPV or EBT, whichever would be the lower value. Now, real quickly, I'm going to just touch on a portion of the PPE presentation for next month. ATPV and EBT will now be our identifiers for our clothing, and this is being replaced. This is replacing the FR rating that we were accustomed to for quite some time now. So from this point forward, FR will no longer apply to the electrical industry. It will be either ATPV or EBT, and we will cover this more next month in the PPE presentation. So while we're looking at our clothing, we also want to pay close attention to the identifiers in calories per centimeter squared, whether it's ATPV, EBT, or FR. This is not identifying the fact that FR is no longer going to protect us. It's just the term is changing from that to the other two. And this is that explanation real quick of the change in terminology from FR to ATPV. You see again at the bottom of this paragraph right here where it identifies the fact that they are all identified in calories per centimeter squared. Next, I'd like to talk on boundaries. Our arc flash boundary is our first one I'd like to identify with. There are 3 boundaries in the code book, 3 boundaries that we must adhere to. The first one being the heat boundary, or typically the outermost boundary known as the arc flash boundary. This is a boundary that exists when an arc flash hazard exists. If something cannot be put into a de-energized state, we must protect against that hazard. So our outermost, typically our outermost one, I should say, is known as the arc flash boundary. It is our heat boundary. This is a boundary that we will establish our barriers, non-conductive barriers. And this is typically, like I said, the outermost boundary. It is the boundary where a person could receive a 2nd-degree burn. So the intent here is to keep people out of the arc flash boundary and protect them against a 3rd-degree burn, which they will find inside that boundary. Anything outside that, hazards still apply, but it is the difference between skin cells surviving and not. And again, we'll cover that more in depth when we get into PPE next month. We have our arc flash boundary, which is our heat boundary, and then here shortly we will talk about the shock protection boundaries, which are known as the limited approach and restricted approach shock boundaries. So our 3 boundaries are made up of the heat boundary and our 2 shock boundaries. Now, while inside that arc flash boundary, I think it's important to point out a couple of thought processes through our code book. These are some requirements that have been introduced recently. One is that while inside that arc flash boundary, employees shall wear hearing protection whenever working inside that boundary. Also, while inside that boundary, they shall wear an arc-rated balaclava to protect the back of the head. Now, this is in conjunction with a face shield. If a person or an individual group decides to go with the hood instead of the shield, then that balaclava would not be required. An arc-rated hood shall be used when the anticipated incident energy exceeds 12 calories. And also if you choose to do so inside of the arc flash boundary, underneath or below 12 calories, you could certainly do so. But just pointing out that a balaclava is required within the arc flash boundary. Again, identifying with the fact that barricades shall be placed no closer than the arc flash boundary. This is the point at which we establish our barriers. Now, the first shock boundary I want to describe real quick here is called the limited approach boundary. It is an approach distance that is identified in our analysis where a shock hazard still exists. Within this boundary, only qualified persons may exist. To sum up, inside all of our barriers, inside of all of our boundaries, all 3 of them, only qualified persons may enter these boundaries. The skills and techniques necessary to distinguish exposed energized electrical conductors and circuit parts from other parts are one of the requirements of a qualified worker inside these boundaries. The term electrical safe work condition is the NFPA's way of identifying with a de-energized state. It is a state in which the electrical conductor or circuit part has been disconnected from energized parts, locked out and tagged out in accordance with standards or policies, tested to verify the absence of voltage or the presence, and if necessary, utilize your temporary grounding systems. So when identifying with our most important thought process here, which is de-energizing, we need to follow these steps right here. The definition of fault current is any amount of current that is delivered on any point of the system during a short circuit condition. And the available fault current would be the largest amount or maximum amount of current capable of being delivered in that short circuit condition. How much is available in a system? Now, this is going to play a huge role in identifying the information on our arc flash labels, or warning labels. Now, those warning labels can either be done through the non-preferred method, which is called the PPE method, which we will cover later in our presentation next month with PPE, or the actual preferred method, which is the arc flash analysis method. So identifying the available fault current, the maximum amount of current that can be present during a short circuit. Now, when we get a ground fault, when we get that energy expelling out of these arc flashes or arc blasts that we recognize with, we call that incident energy. The amount of energy that comes out will be identified in the incident energy analysis. And what actually comes from that, including toxic gases, shrapnel, light, sound, heat, concussion, and so on, that is all known as incident energy. And again, that heat is expressed in calories per centimeter squared. This is a sample arc flash report. This would be the preferred method. And you can see that each one of those lines there would be a label on a piece of equipment. And it goes through and it identifies specifics, distances, heat ranges, opening times, and so on. Again, the definition qualified person pops up. Only qualified persons shall be permitted to work on electrical conductors that have not been put into a safe working condition. Towards the bottom of that, I wanted to bring this slide up to point out that under no circumstances shall the escorted unqualified person be permitted to cross the restricted approach boundary. So there is one exception that applies to the qualified person or an unqualified person crossing into these boundaries. They may do so while under the direct supervision of a qualified person for training purposes, but under no circumstance will they ever cross the restricted approach boundary. Safety interlocks, only qualified persons may defeat or bypass a safety interlock temporarily. As soon as a qualified person is done working on a piece of equipment where a safety interlock was bypassed, they must or shall return it to its operable condition. Moving along, the definition of risk is a combination of likelihood of occurrence of injury or damage to health and the severity of injury and damage to health. I bring this up because this code book is bringing this conversation to the forefront. In addition to other requirements, it is the assessments. The assessments are becoming more and more stringent, and they're incorporating such things as an arc flash risk assessment and the shock risk assessment, as you see on the slide. This, in a short conversation here, is just a requirement along with the labels and so on, but it is actually a very large conversation. But real quick, it is the likelihood. I want to point out that word likelihood also. You'll see that pop up in the code book in quite a few places in a shaded fashion, that being that they want to bring your attention to not only what is present, but what might become present. That is one of the burdens or tasks of the employer to identify the likelihood. Now, this risk assessment takes into consideration a conversation that was started in the 2015 edition, and they went so far as to put it on the front cover of this code book, which is identifying the 6 methods that we're going to address as far as eliminating or dealing with hazards. Number 1 being elimination. It is always the first priority, and it shall always be the first priority in electrical safety, is to eliminate a hazard. If elimination cannot be achieved, then we move on to substitution. We try our best to circumvent or substitute around a hazard. If one of those 2 can't be achieved, then we move on to engineering controls, then on awareness, then on to administrative controls. And you see right here, the very last would be PPE, where most people look at PPE as being the first thing they do when they get to work or when they take a look at an assessment or a job. Really, we're trying to get this mindset reversed where it's the last thing that we should be doing to help protect ourselves. One of those first 5, hopefully, will come into play first. Just imagine a world where a PPE wouldn't be necessary if we could eliminate all the hazards. That would be nice. Now, shock hazard, other than arc being the heat hazard, now we have the shock hazard, is a source of possible injury or damage due to health associated with current that flows through the body by either contact or approach to energized electrical conductors or circuit parts. This is a very serious subject. More times than not, when people think of 70E or electrical safety, they think of the flashes and the blasts because they are visually out there, but 98% of all fatalities come from the shock hazard. So we need to also stress the point of keeping our bodies protected by insulating and isolating using rubber goods. The definition of working distance as it applies to the analysis and these risk assessments and hazards would be the distance between a person's face and chest area and a prospective arc source. Again, we will cover this a little bit more in detail during our PPE presentation next month. The definition of working on. I don't know, were you working on it? Yes, I wasn't. Yes, I was working on it. No, I'm not actually working on it. This is another great conversation to have. Working on is identified in the code book in this way: intentionally coming in contact with energized electrical conductors or circuit parts with either the hands, feet, or other body parts while using tools, probes, or other test equipment, regardless of the personal protective equipment a person is wearing. Now, this is broken up into 2 categories. Diagnostic testing is taking readings or measurements of electrical equipment with approved test equipment that does not require making any physical change to the equipment, and repair. Repair is any physical alteration of electrical equipment, such as making, tightening connections, removing, replacing components, and so on. So I brought this up mainly to identify the fact that you don't necessarily have to be working on a piece of equipment with the panel open or sitting inside a piece of switchgear with that hazard to be there. Sometimes it's as simple as just taking a diagnostic test and using your meter to take a measurement, or making an adjustment to the equipment. That is all considered working on. And this leads to the mindset that while working on something, we must protect ourselves if we cannot eliminate the hazard. Speaking of which, there are 3 instances in which OSHA, Occupational Safety and Health, and the NFPA will allow us to work on energized parts. And it can be found in 1910 333A1. De-energized parts, live parts to which an employee may be exposed shall be de-energized before the employee works on or near them. Now, stress that, on or near them. Unless the employer, it is their responsibility, can demonstrate that de-energizing introduces additional or increased hazards or is infeasible due to equipment design or operational limitations. The third instance, live parts to operate at less than 50 volts to ground need not be de-energized. So the 3 in sum are 0 to 50 volts, while troubleshooting, also known as infeasibility, and number 3, where it could create a larger hazard to shut it down, such as life support system, certain types of alarms, releasing toxic gases, chemicals, liquids, and so on. So these would be the 3 instances that the employer would identify as being necessary to work at Energized. Article 105.3, moving past definitions, we're going to take a look at employers' responsibilities and the employees' responsibilities real quick. The employer shall have the following responsibilities: to establish, document, and implement safety-related work practices and procedures, and provide employees with training in the employer's safety-related policies and procedures. The employee's responsibility, as far as OSHA and the NFPA has identified, is basically the employee shall comply with the safety-related work practices, policies, and procedures provided by the employer. And you see right there, 105.4, the priority in a very small sentence there is hazard elimination. It shall always be the first priority to implement a safety-related work practice. Whenever possible, we eliminate the hazard, de-energize. If it cannot be de-energized, then we must protect against. Training must be provided to not only qualified but unqualified persons. It shall be done. And that training must be provided when an employee is not complying, when there's new technology or equipment that arrives on the job, tests that are performed less than once a year. So if you're only doing some measuring or certain types of testing or certain other types of tasks less than a year, then maybe you need to be trained or retrained. You might need to be retrained if it takes you outside of your regular job duties, or if your job duties change altogether. These are some training requirements identified in Article 110.2. This is an interesting one, Article 110.3. Who is responsible for employees on the job? Who's responsible? And the NFPA 70 is very clear on this issue. Both host and contract employers are responsible for worker safety while on the job. And then it moves on in the code book and identifies different responsibilities between the contract and subcontract employers. But ultimately, the employees are protected by both the host and contract employer. Article 110.6, ground fault circuit interrupter protection. Employees shall be provided with GFCI protection where required by applicable state, federal, and local codes and standards. Listed cord sets and devices incorporating GFCI protection for personnel identified for portable use shall be permitted. They are required in maintenance and construction. Anywhere an employee can interact with electricity and the elements or water, they need to be protected against those potential hazards for shock. Article 130.1, work involving electrical hazards. Article 130 covers the following when electrical safe work condition must be established. The term electrical safe work condition is, again, de-energizing. Requirements for working involving electrical hazards such as electrical safety work practices, assessments, precautions, and procedures when an electrical safe work condition cannot be established are also covered in Article 130. So this is going to be the table that we emphasize next month in PPE. It identifies how to protect ourselves against these hazards using PPE. Do I need to de-energize, or do I need to de-energize? Do I need to find PPE to protect myself? This Article 130, this subsection number 4, normal operation condition. This is a good section to take a look at when trying to identify the types of PPE that are going to be required or even necessary. You can start asking yourself these questions, and this can be done hopefully by the employer's level, but also by the employee can ask themselves, was the equipment properly installed? Do I need to wear PPE? Was it properly installed? Was the equipment properly maintained? Was the equipment used in accordance with the instructions included in the listing and labeling, and in accordance with the manufacturer's instructions? Number 4, the equipment doors, are they closed and secured? All equipment covers are in place and secured, and there's no evidence of impending failure. Now, quite a few times I'm in class or I'm interacting in conversation with individuals, and they say, well, you know, I'm not actually taking the cover off, Mike. I'm just looking at the front of it or identifying some. We need to protect not only while working on or coming in contact with it, but while you're close to it. With the proximity, you need to have that heightened awareness with the potential hazards. They identify the fact that equipment doesn't necessarily need to be interacted with for it to fail. The old rule of thumb is if it's mechanical, it will fail someday. So we need to remember that when we're looking at these 6 qualifiers here for PPE. Energized electrical work permit, when it is required. When energized work is permitted, 0 to 50 volts troubleshooting, and when it creates a larger hazard. An energized electrical work permit shall be required under the following conditions: when work is performed within the restricted approach boundary, and number 2, when the employee interacts with the equipment when conductors or circuit parts are not exposed, but there is an increased likelihood of injury from an exposure to an arc flash hazard. The 4 exceptions to an energized work permit: while testing, troubleshooting, or voltage measuring, during thermography or visual inspections if the restricted approach boundary is not crossed. Access to and egress from an area with energized electrical equipment if no electrical work is being performed and the restricted approach boundary is not crossed. And general housekeeping and miscellaneous non-electrical tasks if the restricted approach boundary is not crossed. So these are 4 exceptions when it is not necessary to pull an energized work permit. However, these individuals still need to be protected against the hazards. It's just the permit they're talking about here in 130.2. Article 130.5, incident energy analysis. Quickly, I want to touch on the labels that are required and when they may need to be required. There are 2 methods by which the information is found on a arc flash label, a warning label. It is the incident energy analysis and the PPE method. If at all possible, we need to do the actual analysis, and if for some reason it cannot be performed, then we do the PPE method. Those labels, real quick, all arc flash analysis labels, all of your warning labels need to be they need to be audited no more than 5 years. So if you've got labels that have been up for a while, I would take a look at the date on them or try to see if they still comply. 2 quick identifiers: if it has a hazard risk category or the prohibited approach boundary. Those are 2 sure signs that that label probably needs to be replaced or updated, I should say. What equipment needs to be labeled? What different types of equipment needs to be labeled? We need to take a look at, and I like the way they word this in the code book. It says electrical equipment such as, and say every piece of equipment that follows. It's just such as. So they're going to leave that up to the authority having jurisdiction to identify which equipment needs to be labeled. So electrical equipment such as switchboards, panel boards, industrial control panels, meter socket enclosures, MCCs that are in other than dwelling units and are likely to require examination, adjustment, servicing, or maintenance while energized shall be marked with a label containing all the following information: nominal system voltage, arc flash boundary, and at least one of the following: available incident energy or your PPE method, minimum arc rating of clothing, site-specific level of PPE, and so on. So as the analysis goes through, you'll see that it can get in great detail, but it is a requirement, even if there's a likelihood to require any of that interaction with that equipment. Again, here's another example of an arc flash analysis. You'll see that these are very specific levels of energy and distances, where the PPE method would give us more of a generic distance. Here is an example of a label. I will identify that there are 3 additional pieces of information that are required on this label that we will cover more next month. But you must have the date on your labels. You must have the person or persons who did the analysis on the label and where that a piece of equipment is being fed from, in addition to the information here. Article 130.6M. I like to bring this up in almost every class that I teach. After a circuit is de-energized by the automatic operation of a circuit protective device, also known as a circuit breaker or fuse, the circuit shall not be manually re-energized until it has been determined that the equipment and circuit can be safely energized. The repetitive manual reclosing of a circuit breaker or re-energizing circuits through replaced fuses shall be prohibited when it is determined that the design of the circuit and the overcurrent protection device involved that the automatic operation of the device was caused by an overload rather than fault. Examination of the circuit or connected equipment shall not be required. So when a circuit breaker trips, we don't re-energize it until we can identify why it had tripped. Article 130.7 is your PPE article in the code book. We again will be covering that. Employees working in areas where electrical hazards are present shall be provided with the employer, and shall use the employee. Those are the two responsibilities in the general duty clause. Protective equipment that is designed and constructed for that specific body part to be protected and for the work to be performed. So it's just, this is that section in the code book that identifies when that PPE is required. This is an update I wanted to bring to your attention today. Shock protection. Employees shall wear rubber insulating gloves with leather protectors where there is a danger of hand injury from electric shock due to contact with energized parts. So this real quickly, without spending too much time on it, as we'll cover it next month, is the section that they're allowing us now to wear our rubber gloves without leather protectors if we can meet all three of the criteria below, and that is found in 130.7A. There shall be no activity performed that would risk cutting the glove. Number two, the rubber insulating glove shall be electrically retested by a certifying agency after we use that glove, and we must reduce that voltage rating of the glove. So basically, we need to wear our leather protectors over our rubber goods. Table 130.7C7 also identifies the time in between these test requirements. We see there that gloves shall be tested before first issue and every 6 months thereafter. Again, we'll cover this more next month. This slide right here is identifying OSHA's programs. Without getting into OSHA too much in depth, this is the map, and it shows the different states, and if they have their own state-run program, the shaded areas, or if they are in white, they fall underneath the federal guidelines. So when OSHA was created and signed into law in 1971, the federal government gave each one of the states and the territories the option to go on their own, to establish their own state-run program. In doing so, you see now there are 26 states, including 2 territories, Puerto Rico and the Virgin Islands, which went on their own and established their own programs. And the rest of them are federally run programs. So that was a quick 45 minutes. If there are any questions, please by typing them in, and we'll go from there.
Yeah, thanks, Mike. Obviously, the number one question we always get is, can I get a copy of this presentation? And absolutely you can. So when you get the follow-up email at the conclusion of the webinar, just simply reply to that requesting a copy of the presentation, and I will email that out to you. Also, if you would like the YouTube link for this webinar, I can absolutely get that to you, as well as we'll be posting it on our YouTube channel here in the next day or two. But if there are any questions, you do have the question bar there on your GoToWebinar bar on the right-hand side. Please just type those in, and we will get those answered for you. So we're starting to get a couple here. Again, to get a copy of the webinar, just respond to the email that you will get at the conclusion of the webinar, and I will email it out to you. Mike, as we wait for some questions to come in, do you have any last-minute thoughts about avoiding arc flash and arc flash injuries and incidents? Mike, did I lose you?
No, I'm here. I'm good.
Okay. Do you have any parting thoughts about arc flash as we get our questions in?
Oh, okay. Thanks, John. I just wanted to let everyone know that this was a very, very brief discussion on this subject matter. It's very detailed, and it's a larger conversation that everyone needs to have. But it is real. It does happen. I've unfortunately had some experience with it, and I just hope that everybody takes this seriously when they're setting up their safety programs.
All right. First question we have in, Mike, is where do you go to have your electrical PPE inspected for reuse?
Okay, when we're talking about PPE and the clothing, that would be identified by the manufacturer, and it shall be kept clean in a good working order, mended, and so on. If you are by chance getting your clothing through someone like Cintas or Aramark, they are required to keep track of how often it is laundered and how it's laundered. If you are laundering it yourself, as far as PPE clothing is concerned, make sure that you're following the guidelines of no bleach or chlorine-based detergents, no high temperatures, and absolutely no fabric softeners whatsoever. Now, if you're talking about PPE in the form of rubber goods, that would have to be done by an established and someone who has the qualifications to do that testing. They have to be certified to do that type of testing. And you can find them in your local area.
All right. Mike, does older electrical equipment need labeling specifically for like arc boundary labeling or nominal voltage, things like that?
I believe that question is for legacy equipment or for the older grandfathered. Some people use the term grandfathered equipment. The best rule of thumb to keep in mind is if a hazard exists, we need to be protected against it. So yes, that older equipment would also need to be labeled.
All right. Thanks, Mike. Mike, can you elaborate on what an OSHA 10-hour card is, please?
Sure. An OSHA 10-hour card is a introduction, if you will, to general safety, and it covers such things as slips, trips, falls, fall protection, electrical hazards, ladder safety, and so on. And the bigger brother to it would be the 30-hour class, and it goes more in depth to the different subjects, SDS, and so on. So that 10-hour is basically an introduction to safety as OSHA is concerned.
All right. Okay, we're still waiting for some more questions to come in. But again, if you need a copy of the presentation, just respond to the follow-up email that you'll be getting here as soon as the webinar concludes, and I will email that out to you very, very shortly. Also, if you'd like a copy of the presentation in a video form, you'll be able to view that on our YouTube channel, and I can send you that link as well. I don't see any more questions coming in right now, so we'll give people another couple of seconds. All right, well then I guess we'll wrap it up there, Mike. Any parting thoughts?
I appreciate everyone clocking in today and listening to this presentation. Please give your questions a good thought process and get them into us, and I'll do my very best to get you a good answer. Thank you very much.
All right, and lastly, before we guys let you go, I did post the registration link for the PPE specific electrical safety webinar in the chat bar. So if you would like to get signed up for that, obviously free as they always are, please feel free to do so. So we will end it there. Everyone, thank you very much. Mike, thank you very much. Have a good day, and everyone stay safe out there.
Thank you.